Hello everyone, today I'm going to talk about algebraic identities, namely these two sum of squares and square of a sum. I will show that they are different, but they are extremely important in the solving equations and algebraic expressions in school. But first of all, let's explain that they are different, although they look very similar. So if you take a squared plus b squared, so these are symbols, letters in algebraic expression, which can be represented by any number. You can substitute it with any number. So let's see what's gonna be the result if you plug in 2 instead of a. 2 squared plus, let's plug 3 for b. So first we will calculate exponents, because exponents, according to order of operation, are first. You know PEMDAS. PEMDAS is P for parentheses, brackets, E for exponents, M for multiplication, division, addition, and subtraction. So of course, here we have to first do exponent. So it will be 4 plus 9 equals 13. But you will get this result if you use sum of square, but you will get totally different result if you use square of a sum. So let's take a plus b squared. It's gonna be 25, not 13, because of course if we plug 2 and 3 for b, it's gonna be 25, and a is we could you see the brackets, so first we could add 2 plus 3 and then raise it to the power of 2, so it would be 5 to the power of 2 equals 25. But generally when we see square of a sum, we need to expand it. Here I didn't expand it when you see the real numbers 2 plus 3, but with these symbols we need to expand it to this form which you see here, a plus b, a squared plus 2ab plus b squared, right? So you will take 2 to the power of 2 plus 2 times 2 times 3 plus 3 to the power of 2. So this is this ab because a is 2, b is 3, so 2 times 2 to the power of 2 is 4 plus 2 times 2, 4, 3. 4 plus 12 plus 9, you also get 25. So as you can see, we could just add it in the brackets first, then raise it to the power. But if you see sum of squares, you have to raise it to the power first. So this is an interesting difference between them. And now let's do a practical exercise in which I show you in practice that they behave differently and we can gather different information from using them. Okay, so let's do a geometry exercise. We have a triangle. This is a very common exercise. Some of you probably know it, but if you don't know it, hope you can enjoy it. Okay, so we have a right triangle. Right triangle means that it has 90 degrees here, 90. Then we have a hypotenuse. This is hypotenuse, which is 6 unit long. This is 6. The longest side is in the triangle is called hypotenuse. And in this triangle, there is a circle inscribed in it. There is a circle, and this circle has a radius r equals 1. Okay, so that's all the data we have about this triangle, and we need to calculate the total area of this triangle. How to do it? You know that the formula for area in a triangle is a half times a times h. H is height. Height is here. It's not known. We can represent it as height as b, and the base is a. But we don't know a. We don't know height, so we are unable to calculate it. But what we know is only hypotenuse and radius. So first of all, we need to know something about height and base. So we will get this information using in-radius theorem, which says that a plus b minus c divided by 2 equals 1. And from this formula, we'll be able to extract what is AB, because we are interested what is AB. Okay, so let's extract it So how we're gonna do it? First, we will multiply the two sides by 2. So if you multiply it by 2, you will cancel out 2 from the denominator. Okay, so we've got 2 equals a plus b minus c. I correct this. Okay, 2 equals a plus b minus c. And again, now we will add c to both sides to eliminate c from one side, because it will cancel out minus and plus. So we will see that c plus 2 equals a plus b. How much is c? C is 6. So we know that 6 plus 2 equals ab. So we know that a plus b equals 8. Okay, so it's a very important information. We already know a lot. We know that c equals 8 and a plus b equals c equals 6. C equals 6, but a plus b equals 8. Okay, very important information. I'll keep it here, and I will erase this one, because from as you can see, we are unable to say how much is b, how much is a, but we know how much they are together, and later we will process it further to find the answers. We will use square of sums, and we will use Pythagorean theorem to find the answer. Okay, let's go further. So we know that a plus b equals 8. So look what's going to happen. We know that Pythagorean theorem tell us that a squared plus b squared equals c squared. So we can say that a squared plus b squared equals 36. We also know that a plus b is 8. Therefore, using square of a sum, a plus b, and here we write it in brackets, squared, equals 64. So that's what I was talking about this difference. So a squared plus b squared is equals 36, but a plus b squared is equal 64. And knowing this, we can set up a simple equation, and from this equation we're going to extract how much is a times b. Why do we want to know how much is a times b? Because a times b will tell you what is the area of a triangle. A times b divided by 2. So we don't need to know exactly how much is b, how much is a. It's enough to know how much is a times b, and work around to find the answer for area, not knowing the length of sides, each side, but they length together. So let's write everything in this. Let's set up the equation. So we write 64, because we know that a plus b squared. So we know that 64 equals, what does it equal? A squared plus ab plus b squared. And now we have to set 2ab, right? Equals plus 2ab. So 64 equals a squared plus 2ab plus b squared. So we already know what is a squared, b squared. So we can continue like this. Instead of writing a squared plus b squared, we can write 64 equals 36 plus 2ab. Okay, because we know a squared plus b squared, we wrote it here, equals 36. So we don't have to write them, we can replace them with 36. So 64 equals 36 plus 2ab, and from this equation we can calculate what is AB, and we will then be able to know the area. So AB, 2AB equals, we have to minus 36, right, from the right side. We remove 36 from this side and we will know what is AB. So 2AB equals 64 minus 36, which is 28. Okay, so we know that 2ab equals 28. This eraser is too small. Okay, so knowing that 2ab equals 28, we can divide it by 2. So we have ab equals 14. So now we know how much is a times b. How much is base times height is equals 14, but the area is, as you can see it here, area is a half of base times height. So half of 14 is divided by 2 is 7. So finally we found the area of this triangle using sum of squares, which was Pythagorean theorem in this case, and square of a sum to extract AB base times height. So I hope that this exercise shows you clearly that sum of squares is different than square of a sum, and now you'll be able to use it in practice. Thanks for watching. See you in the next